repetitions. In this video, I'm going to walk through just a good basic factor flow to do that you can use when factoring polynomials. Now, before we start, it's really important to know that, watch out, not all polynomials can be factored. As we're practicing, every polynomial you've been given can be factored, but don't be surprised as you go along the way if you encounter polynomials that can't be factored. All right, so here we go. You're given a polynomial. What is your flow? What are your steps to go ahead and factor it? Step one is always, do all the terms in the polynomial have a GCF? And if they do, your first step is to factor out the GCF. Whenever you can factor out a GCF, it always makes whatever you're factoring easier. Sometimes that's the only thing you need to do. Other times you move on to others. Okay, the next thing you check for is, does the polynomial have 4 terms? And we'll go through an example of this. And if it does have 4 terms, you're going to try to factor by grouping. So there are 4 terms. Try to factor by grouping. And I'm putting try because sometimes it will work and sometimes it won't. And typically when we're factoring by grouping, we're going to put those terms, those 4 terms, we're going to put them into pairs. So terms into pairs. For this, I'd love to go through 2 examples, one where you can and one where you can't. So we'll come over and do 2 examples for this, a yes example and a no example. If I'm looking at the polynomial 2x to the third plus 3x squared plus 2x plus 3. I'll look at these, I'll group them into pairs. The first pair has a GCF of x squared. I'll factor that out, and I'm left with 2x plus 3. I can always check myself by redistributing to see if I get back to where I started from. The next one, I notice the next one is already 2x plus 3. So the GCF I'm going to factor out here when I'm factoring by grouping is 1. So I have 1 times 2x plus 3. And now with factoring by grouping, I'm super excited when I notice, hey, I've got the same binomial here. That binomial is the GCF. That gets factored out. And for each term, my remaining factors are x squared plus 1. And I'm factored. So there's a polynomial that, yes, this one can be factored by grouping. Let's look at a second example. I'm going to put another example down here. Let's do 2x squared minus 2x plus 6x plus, what did I have for my example there? Plus 6. Again, I'm going to put them in pairs. And for my first pair, my GCF is 2x. Let's factor that out. And I'm left with x minus 1. And then for my next one, my GCF is 6, which leaves me with x plus 1. When we do this, we notice that that binomial is not the same. So those 2 terms do not have a GCF. So I can't factor this by grouping. So this was a no example. All right, factoring by grouping is super helpful when 4 terms. They're more complex, sophisticated ways where you might have 5 terms or 6 terms, but really focusing on the 4-term version. Next thing we're going through our checklist is step 3. Do we have a quadratic? And does the quadratic match this form, ax squared plus bx plus c? For quadratics, a cannot be 0, but sometimes b is 0 or c is 0, so don't let that throw you off. We're looking for a quadratic. Now, when we go to factor quadratic, what we're doing is we're looking for 2 numbers. I'm just calling them m and n. And those 2 numbers need to add together to be b, and they need to multiply together to be a times c, a times c. Now, when a is just 1, sometimes we say they have to multiply together to be c, but that's just because a times c, when a is 1, that just gives you c. And this reduces just to a simple diamond puzzle. Over here, can we find these 2 numbers that multiply together to be the product of a times c and add together to be b? Try the diamond puzzle. Can you solve it? Can you find those 2 numbers? If it's no, what that just is telling you is this quadratic cannot be factored. Might be a little sad, but this happens all the time. Again, you haven't seen this very often because I've been giving you quadratics that you can be factored, but don't be surprised. It's going to happen to you. What about the yes case? When you can find those two numbers that solve the diamond puzzle, your next thing to think about was a equal to 1. When a is equal to 1, excuse me, you can use the shortcut that this is going to factor into x plus m times x plus n. Excuse me, I'm going to get a drink of water. Hold, please. All right, I'm back. So that's the shortcut. If a is not equal to 1, it might be another number. You're going to split that middle term. So with no, you're going to split the middle term. So it's going to look like something like ax squared plus mx plus nx plus c. Once you split that middle term, notice you have a polynomial with 4 terms, so you're going to factor by grouping and factor by grouping. All right, so that's how you do a quadratic. Finally, our step 4 is we always go back and see, can any of the, like let's say we factored a GCF or we factored a quadratic, can any of the remaining factors be factored further? And to do this, you're going to go back to step 1 and go through the process again. For more complex polynomials, sometimes it takes 1 or 2 cycles through this to fully factor a polynomial. Just like when you're factoring, finding the prime factorization for a number, sometimes it takes a couple of cycles of going down and finding more and more prime factors. Mathematicians, I hope this has helped to you solidify and deepen your understanding of factoring and factoring quadratics. And don't be surprised if factoring polynomials. Don't be surprised if you encounter polynomials along the way that can't be factored. Time for a lot more practice, and please ask questions as you're going along. All right, see you soon.